This conference will now be recorded.
Okay, so today we are going to discuss about Spark, but before we discuss about Spark, so I want to make you understand um, what was the processing system before Spark. If we know about that processing system before Spark, we can easily appreciate the Spark. Okay, so I just want to uh, make you guys understand what was the legacy system. We can call it as a legacy system, which was an older system, and how it was working. Then how the Spark is better. Okay, because this is also one of the most frequently asking interview question. What is the difference between MapReduce and Spark? So whatever the legacy processing system I was talking about, we'll call it as a MapReduce. Okay, let's see. First, let me give you a brief introduction about a Spark. Then I'll go with the uh, MapReduce. Okay, Spark, Apache Spark. Spark is Spark is by definition it is general purpose general purpose cluster computing system. It is, you can call it as another way also, lightning fast distributed lightning fast distributed general purpose cluster computing system. If you closely observe the definition, it is a cluster computing system. It means it is a processing engine. It's a processing engine. Okay. Spark is a data processing engine. It does not have a capability of storage. It cannot store. What it does, whatever the process you want to perform, whatever the operations you perform in the background or in the foreground, whatever the operations you apply, those operations will execute. But how it will execute? In a distributed manner, lightning fast. It means too fast, faster, and and general purpose. When I say general purpose, the meaning of it is not only specific to one file system. It is not only specific to one use case. You can use a Spark as different file systems. You can use in different programming languages. You can use a different frameworks or different libraries, I can say. Okay. So by definition, or to make it very simple, Spark is executing system. Spark is an executing system. Okay. So is there any other executing system before Spark? Yes, there was a executing system. There was a processing system that was called MapReduce. Okay. Let me show you the definition of the Spark. Then I'll jump into the MapReduce. Okay. So the Spark has a beautiful, what I can say, um, um, a release notes or a documentation. Okay, it has a beautiful documentation where you can actually make use. You can see that release notes or a documentation to understand more about the Spark. Okay, let me show you what is Spark. What is Spark? Apache Spark. I could say Apache Spark. Okay, if you go to if you go to let me take a documentation. If you open the documentation, you can also see. You can see Apache Spark is unified analytics engine for large scale data processing. It is a data processing engine. See, from the way earlier versions and all, it was the definition is clear changing, but the definition looks changing, but it's not actually. Earlier it was lightning fast. Then they have captioned it. They have given tagline as a lightning fast execution system. Similarly, here also unified analytics engine for the large scale data processing. It provides a high level API in Java, Scala, Python, and R, and an optimized engine that supports general execution graphs, supports a rich set of high level tools like Spark SQL, machine learning mlib, graphics, and structure streaming, and so on. Right? It is a clearly it is what it is saying. It's a data processing execution engine or data processing system. It is a data processing system. Okay, let me click on this. Okay, so I'll take you through this documentation later in detail. But let's before Spark, before Spark, is there any other processing system? Okay, so that we will understand. Before Spark, is there any other processing system? Yes, there was a processing system. Before Spark, there was a other processing system that's called Mapreduce. We might have heard about it earlier also when we are doing a scoop, when you are doing a hive. I mean, you guys have gone through these two frameworks, right? So in these two frameworks, we had seen that Mapreduce execution, like a map execution, reduce execution, and we have seen some kind of a log information, right? So how the Spark is better than MapReduce? So to answer that question, first we need to understand what is a MapReduce. First we need to understand what is a MapReduce, how it will work. Okay, so let me give you more detail about MapReduce. MapReduce. Yes, as it says, MapReduce is a processing engine. So how to come up with the two components? One is the HDFS component, other one is MapReduce component. MapReduce, it is a processing engine. So HDFS for the storage, MapReduce for the processing. That's what we have learned, right? So if you see closely here, it is a two operations, guys. It's a map and reduce operations. It's a two operations. What are they? It's a map operation and reduce operation. This framework, MapReduce framework, was developed using Java, and it was used mostly in Java only, Java programming language. But it can be used in Scala, Python, and recent APIs. Scala, Python, and all it can be used. But earlier it was developed by using Java, and most of the people are using Java only. Next, other part. This MapReduce framework works based on the key value pair. It has its own data types. It has its own, I can say, like interfaces. It has its own abstract classes. So this MapReduce framework, what it does, let me explain a pictorial representation. So if I have a data in HDFS, I can launch my MapReduce job. When I launch my MapReduce job, the first it will launch a map job. Without map, there won't be any reducer, but map can be without reducer. There are two type of jobs: map reduce, map and reduce, map only. There are two jobs. Okay, map reduce means right after the map there is a reduce operation will go through, but here there is no reduce operation, only map operation. So there is no reduce alone job. Okay, there is no reduce alone job. Map should happen. I'll explain what is a map job, how it will do. Map job is very simple, mapping the data and processing, initial process. Okay, what it does, this Mapreduce framework will process only HDFS data, and actually most of the cases it will process only HDFS, but in a few libraries are there that will also process the data from RDBMS. Apart from, it will not support any other file system. It will not support any other file system. It supports only HDFS, and with the help of the some libraries, it will support RDBMS. Okay, so now you understand, right? So Mapreduce will read data only from HDFS. If you launch your Mapreduce job, it will read the data from HDFS. It will process as part of the map. This map output, it's input, right? It's input, and map after process will be having output. This map output will go to reducer. Map output will go to reducer. It is also input here for the reducer, and it will be output here. This output will write into HDFS. Okay, it's a simple Mapreduce job. If you observe it closely, it is reading the data from HDFS. HDFS is a disk or memory. HDFS is a disk or RAM.
The disk.
It's a disk. It is a disk. You take any process, no matter whether it's a Scala, Java, or any process, every process will run in the memory. Any process, you take any process, even your mobile, your computer, everything, the process will happen in the memory only. It can be a map process, it can be a reduce process, it can be other, it can this, whatever the process, it will happen in the memory only. It means RAM. So the map process will happen in the memory. When you say memory, it's RAM. Okay, and the mapper output will actually go to the disk. Mapper output will actually go to the disk. From the disk, it will read. Reducer will read. Again, reducer will happen in the memory. Finally, the output will write into disk. Whatever the data you write in the disk after the memory, whatever the data you write into the disk after memory, or your mapper output, your mapper output mapper output we will call intermediate data. Intermediate data. Try to remember this. This is the most important keyword. Intermediate data. The mapper output will call intermediate data. If you see here, it is fully dependent on the memory. Disk. Your MapReduce has more dependence on the disk. It means here it has to read. Here there is a one IO, input output operation, from the disk, and it will write. So here also write and read is there, input output operation. Again here it will write. You also have an input output operation. It means there is a lot of read and write from the disk. There is lot of read and write from the disk. When you have a more read and write from the disk, your performance will be less. Very simple, guys. Reading from the disk is slower than reading from the memory. Any process can read data from memory, which is RAM, will be faster, but reading from the disk is slow. Okay, so here your Mapreduce job has, it's a simple job, one map, one reduce, one map and one reduce. Suppose if I have another job which is depend on the output of previous job, again here another map, again here another reducer, again here HDFS. This is called Mapreduce chaining. Till here we'll call one job, till here we'll call one job, from here to here is one job, from here again one more job. So we'll call Mapreduce chaining. Okay, so if you have a lot of chains like this, you assume lot of disk IO. When you have a more disk IO, when you have a more disk IO, obviously the performance will be less. Okay, now let's try to understand how the Mapreduce process the data. So it's a very high level, right? Let's try to understand how Mapreduce process the data, how it will read the data from the HDFS and how it will process. Okay, first, as I told you, it read the data from HDFS only. It will read the data from HDFS only. Okay, and actually Mapreduce framework depends on the key value pair. Depends on the key value pair. Your mapper also works based on the key value pair. Your reduce also works based on the key value pair. Mapper works key 1, value 1, and its output will be key 2, value 2. I can call it as a emitting. After this, what it does, your reducer will take from here. No, it's the input, it's output. It's input and output for the mapper. Then from here, your reducer will start. It will take this key 2 as input. It will emit as key value pair. So here it's input, it's output. What do you observe here? The mapper output will be input to the reducer. The mapper output will be input to the reducer. So what is this key 1, value 1, key 2, value 2, key 3, value 3 and all? What is this, sir? I'll tell you. Even though if you have given a file to, even though if you give a file to your Mapreduce job, it's a file. Okay. There is something called input splits. We'll talk about that in a few minutes. Let's assume that it's a file. Okay, let me do one thing. It's my file. This is one split. This is a file in HDFS. These parts will call input splits. Input splits. Okay. Do you guys remember we discussed about input splits earlier? Did we discuss any time input splits? Did we discuss any time input splits? No? Okay. If it not, we'll discuss now. Do you guys remember while processing your scoop job or while processing your hive job, have you seen that number of splits? Have you seen the number of splits? While launching your Mapreduce job in scoop,
Yes,
I have
Ravi.
shown the number of splits equal to number of mappers. Do you guys remember that point?
Yes. Yes,
Number
Ravi.
of, yeah, this is same one only. This is same one only. Okay, the file will divide into splits. How it will get divided and all I'll explain you. I think if I remember correctly, I have taken the formula and also explained you. I'm not really sure whether you guys remember or not. For if not for this batch, anyway, I'll cover that again today. Okay, so your whole data will be divided into splits. So these pieces we can call them as a splits. Normally we'll call input splits. Input splits. Input split. Let's say this input split 2. This is input split 3. So even though if you have a file, while reading your map job, what it does, it divides into the whole file will be divided into input splits. Then one split will go by one mapper. Actually, one split will process by one mapper. That's called actually mapping. Mapping your logic to split. Mapping your logic to the split. That's called actually we'll call it as a mapper phase. And it will read the data also. Okay, don't where is my cursor? One second. Right, saying it's not very nice. Am I audible to everyone?
Yeah, Ravi.
It looks my
Your voice is not that clear actually.
yeah. Actually, it got disturbed. I don't know why
Yeah, it is
it
good.
is happening.
It is good now.
I need to get it repair this laptop. It's saying that it is not supported. What happened to this? Speaking on due to the computer malfunctioning. Windows does not recognize it. Try reconnecting to the device. It's still not. Yeah, now it is recognized. I don't know what happened all of a sudden. Even my machine, since yesterday I have it isn't plugged only, it is showing only 60% and saying not charging. If you see here, maybe the battery is gone. I need to get it ready. I will check. And that to this corona time, I cannot go here or there. Okay, look at here, guys. So what it does, every split will be processed by one mapper, as we know that, correct? Every split will process by one mapper. Map 1, it's a map 2, it's a map 3. It will process by map. Okay, so your logic, your mapper logic, whatever the code you write in the mapper logic, that will map to split and it will process it, it emit the output, it will write into the disk again, some reducer will take. Okay, how this map will read the disk data, that's the point. How this map will read the data. Okay, so the Mapreduce framework is, as I said, like collection of different frameworks, different libraries, right? Different libraries and classes and interfaces, right? In this split, actually there is something called record reader. There is something called record reader. What it does, it reads a line, record. Actually, line will call as a record. Okay, it will read the line. It will read the line. Your record reader reads the line and split into key value. How it will split into key value? Based on input format. There is something called input file format. Did we discuss about these things? Input file format. Based on input file format. Suppose if it is a text, by default text, okay? By default text input file format. If it is a text, my key will be offset. Offset. My value will be complete line. How many knows what is the offset? Offset is nothing but it start with a 0 first line. Okay, start with a 0 and it count the number of characters in that line 1, 2, 3, 4 and so on. Let's assume that 150 characters are there or 100 characters are there. The next line will be 101. Suppose of 50 characters are there. Next line will be 151. Okay, so offset is like that, not the line number. Don't get confused with the line number and offset. Offset is actually start with a 0. Start with 0. Number of characters in that line will be counted. The next line will be next count. Let's say I have started with 0. 100 characters are there here. The next line will be 101. Okay, offset, which is a number. Line is a string. Are you guys getting, guys? Any confusion or any, if you are not able to understand, please ask me. I'll try to put in a simple way, or I'll try to make you understand. Is everyone is following till here?
Yeah, Ravi.
Yes.
I'm hearing only two voices. I don't know about others.
Yes, sir.
Sudhir,
We are able.
Ashok, Sairam,
Yes.
Prem. Okay. So if you have a data in your file, the file will be break into inputs, input splits, that every input split will read by line, it will read. Okay, don't assume that it will take whole input split and process at a time. No, it will read line by line. It will process line by line. Okay, so your mapper, what it does, it called the record reader. Actually, record reader mapper internally record reader will be there. The record reader will read the line. It will break into key value pair. That key value pair will give to the mapper. That key value pair will give to the mapper. So this map method, we will be having a first argument 2, right? The first argument is your key. The first argument is your key. The second argument is your value. Okay, let me show you a simple code, simple Mapreduce code. Where is that? Okay, sign out. Okay, that's a result. Where is my Mapreduce? Mapreduce. Okay, let me show the simple one. Word count job. Okay, look at here, guys. This is the driver program will call. Okay, this is actually driver program will call. Let me go down. This is your mapper. You can have a separate files. Okay, mapper is separate file, reducer is separate file, separate files. Okay, look at here, class word count mapper extends mapper. Okay, and it's a input one, key 1, key 2, sorry, key 1, value 1. What will be the output of this? You're specifying in the class level itself, but when you see the method line number 115, look at the line number 115, long writable key. I told you, right? It has its own data types. Long writable is one data type in Mapreduce framework, but it's not really required now to understand in detail. If anyone is interested to know in detail, in our YouTube channel, I have a separate Mapreduce videos are there. I think close to 20 videos are there. Please go through videos. It has in detail, everything has been covered there. Okay, but it's as part of these days, no one is asking Mapreduce, but only one question people is asking: what is the difference between the Mapreduce and Spark? What is a combiner? What is a partitioner? It's everywhere is the same. We'll discuss about them. Okay, so long writable is one of the data type in the Mapreduce. Long writable, int writable, float writable, double writable. Okay, similarly text. So we'll call string in normal programming language. We'll call string, right? Here it is a text. Okay, so look at here. This is the key and this is the value. Okay, so your map is taking 2 arguments, right? These arguments data types, if you see, is equivalent to this. And if you see context.write is nothing but you're emitting your output. You're emitting output of the mapper. You're emitting. The map method will not return here, it will just write, it will emit into the disk. Okay, context.write means it will write into the disk. Okay, so look at here, word is what? Is a text type. Look at here, what is the data type? Text type. What is text type? And int writable. Look at here, int writable. It means if you closely observe, output key, output value. Okay, whatever the data you give, it will break into input splits. That input splits will read by the record reader. After record reader reads it, the record reader itself will convert to key value pair. That key value pair will come to your map method. So key will be your offset, value will be complete line. So I have explained here. Your key will be offset, value will be complete line. Then internally it's your own process. You are converting your value into string, and you are breaking the string, here it is, string tokenizer. You are breaking the string, right? After breaking the string, you are looping through this those tokens, and you are actually emitting. I mean, that's your logic. So the word count logic. Okay, are you getting what I'm trying to show? What I'm trying to show here, your input data is broken into input splits, and it will, after reading line by line, so try to understand, guys, your map method will execute for per line for one line, one mapper. I mean, every line the map method will execute. Mapper is your object. This is the mapper, your object. Map method, this is map method. Mapper is one object. Map method is one method in the object. This map method will get called how many records are there in your input split. Suppose if I have 1,000 lines in my input split, your map method will get execute 1,000 times. Similarly, your reduce, look at here, your reduce, it is taking text. Look at here, compare. Your mapper output is word is text type. Word is your text type. Here also text type. Your mapper output int, here iterable of int. Why? Because when it comes to the reducer, in between there are two more processes happens. Shuffling, grouping, sorting, there are other operations will happen. When those operations happen, your values will be collected as a group. Iterable. Where we have discussed about iterable? In the recent classes only, right? Iterable means collection. Iterable means group. Okay. So after performing your mapper output, shuffle and sorting and grouping, it will come like this, guys. This is what I want to show. Look at here. HDFS is the key. 1111 is a collection. It's a group. 111 is your value. Then you loop through your values, and whatever the operation you want to perform, you will perform. So the main intention of showing this is your Mapreduce framework will works based on the key value pair. Is this clear to everyone?
Ravi, what is difference between mapper and map method?
Mapper is an object. Mapper is an object, right? Mapper is your class. You have written mapper class. In that, actual operation happens in the map method. Mapper is your parent. See, let me put it in this way. If this is my own class, right? This is my own class, correct? If my own class should get mapper behavior, like reading input splits, reading the line by line, processing it, if it should get that behavior, it should extend the parent, right? Yes, no?
Yes.
That behavior gives by your mapper. That behavior gives by your mapper. This is the mapper. Okay, the mapper phase. This is called map phase. Whatever the operation perform in the map level, that will call mapper phase. Whatever the operation perform in the reduce level, will call reducer. Okay, these are the parent classes. You can write any name here. You can write my reducer, my mapper, or only my name. You can write anything, but you have to extend this. When you extend this, then only you will get that flavor. Otherwise, you will not get that flavor. Okay, yeah. For more details, please go through those videos. That videos will really help you to get the concept, Mapreduce concept. Okay, if it's possible, I'll share that link in the group. It is possible, I'll share that link today. Okay, let's go ahead and continue with how internet work. Any doubts so far? Any doubts so far? So why we are learning this, why we are understanding this? The only reason is if you understand how the data is getting processed here, how it is behaving here, you can easily understand how it will be, how it is different in Spark. You can easily understand and you can easily appreciate that Spark behavior. Okay, those days Mapreduce is the only framework. Those days Mapreduce is the only framework. There was no other framework. Mapreduce was the fastest framework those days. Now the Spark is more faster than Mapreduce, so everyone is talking about Mapreduce and everyone is talking about Spark. And Spark has a lot of contributors. A lot of improvements are happening. Lot of improvements are happening in the Spark. So it has a lot of flexibility. See, if you go with the Mapreduce, you should know Java language or Python or some other language. Earlier, I didn't see anyone using Scala, Python for Mapreduce program. I see everyone is written in the Java only. Second challenge is, suppose if I am from SQL background, I want to write SQL kind of queries. Mapreduce will not support. Mapreduce is only how to write a plain Java code. If you want to apply that SQL kind of operations, you have to go with the highway again. But I want to apply that operations, SQL operations on the file. You cannot do. But that can be done in the Spark. I'll show you. We'll talk about those things in coming classes. Any questions so far? I know more theory today, but that's how this framework is. It'll read the it'll read the line, it'll break into pieces. That pieces will go to the map method will process it, and it'll emit the output based on the condition or based on the operation. Similar happen to the next line, similar happen to the next line, similar happen to the next line, and it will happen parallelly. Split one will be processed by one mapper. One mapper means one instance, separate instance it is. One map process. Split 2 will process another maps. Split 2 will process another map process. Split 3 will process another. So it's a parallel processing. Again, it's a parallel processing. Don't assume that one split 1 is complete, then split 2. No. It's again a parallel processing. Okay. Next. If no doubts, I'll go with the next concept or next detail. Is everyone is clear? So much of silence. I don't know whether you guys understood or not.
Yes, sir. Clear.
Venkat, Sudhir.
Yeah, Ravi.
Yes, Ravi.
Yeah, I know that it's little see, if it is some program or some operation, some method, you can easily understand, you can do the hands-on. But it's a framework. We're trying to understand the framework, internals of the framework. So it looks little confused, but if you go back and refer it again, you'll easily understand. Okay, Mapreduce framework comes with the two methods: map method, reduce method. The map method will execute first, reduce method execute next. If you don't have a reduce, there are some cases, there are some scenarios or use cases where reducer is not required. Only with the map itself we can solve the problem. So that kind of cases, we'll go with the map only jobs. A simple case, I want to convert, let's say I'm reading a different file format, JSON files. I'm reading JSON files and I want to convert into text files. I don't need a reducer here. Reducer is mainly used for the aggregation purpose. Reducer will be used for aggregation purpose. So wherever you don't have aggregations, you can simply go with the mapper. Okay. Let me show you the architecture, how it will work. That one. It actually takes few more extra minutes. Okay, just please bear with me. Compared to our normal session, it will take some more time. First, we'll be having the HDFS layer. And in this HDFS, let's assume that it's a HDFS. I have a file in this HDFS layer. Okay, the file is in, let's say, slash apps slash user slash data. In this, I have some log file. Let's say it's a Amazon log. It's Amazon log. Okay, forget about block size and all. Forget about the block size and all. Okay, here block sizes will be considered, but that's not a that's not the primary, or that's not more important here. Input splits are more important. Let's talk about how input splits will be calculated. Do we discuss about this formula earlier? I think we discussed. Yes, no?
Yeah, Ravi, we discussed during 5.
Yeah. I think, do I need to cover that again? Input splits? Okay, let me cover it again. Okay. Let's say this is my file and my block size is 128 MB. My block size is 128 MB. The formula to calculate input splits is, can anyone tell me? Input split size, actually it is input split size. Okay, input split size equal to, can anyone tell me the formula? Max of min input split size comma min of max input split size, we'll say split. Okay, max split comma block size. Do you guys remember this formula? Now max of, can anyone tell me what will be the minimum split size? One only, no? Minimum will be one only, right? Zero won't be there, minuses won't be there. One. Min of maximum, this is the important one we need to understand. Maximum is a very big value, guys. It's a um, long value max boundary. So I think you guys remember while discussing about data types, we discussed about every data type and their boundaries, right? Similarly, there is a max limit of your long value. Okay, let me see. Okay, I wanted to know value, not in this. This is the maximum value. Okay, so here it's a biggest value, comma, that's the formula, right? Comma, what is the block size? So 128 MB, 120 MB in bytes, 128 MB in bytes. It comes close to, okay, let me calculate it. It takes a calculator. 128 into 1000 to 4 into 1000 to 4, correct? 128 into 1024 will be kilobytes, into 1000 will be bytes. So this is the number. Try to remember this formula, guys. Earlier people used to ask, in initial days, people used to ask, uh, in earlier days people used to ask how you will calculate the input split and what is input split and all. Okay, now no one is asking, but if anyone asks in an interview, you should be able to answer it. So what is the minimum value between these two? What is the minimum value between these two? Block size only, no? Yes or no, guys?
Yes.
Yeah, block size.
Block size.
And what is the maximum between these two?
Block size.
So the input split size is equal to block size. In case of text input file format, you need to remember this. In case of text input file format, this is not true in all the cases. Some cases it go beyond your block size. Okay, you tell me now, if I want my block size, my input split size should be more, bigger one. Where I need to do the change? If my input split size should be more, I don't want to be size of the block size. I want my input split size should be more, bigger. Which value I need to change? In this formula,
Can you
which
repeat?
value I need? Okay. Now my input split size is equal to block size, right?
Hmm?
I want to bigger size.
We should increase block size.
If you increase the block size, again the block size only you will get, no. But increasing the block size will be impact on your file system.
How about increasing the minimum number of input splits?
Yes. 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 Minimum input split size you need to increase. Okay. So instead of one byte, I'll increase my minimum input size. Let's say I want 256 MB. So whatever the 256 MB value will come, here I'll keep that. I'll increase that minimum input size, this size. Then I'll easily get my block size will get my input speed size will get increased. My input speed size will get increased. So that's the reason in the program, right? You have a control on the increasing and decreasing your input speed size. Increasing and decreasing in the input speed size in your program. You can do that in your Mapreduce program. Okay. Now, can anyone tell me what is the difference between block versus input split? The most
Input
important.
slit, input slit is logical division.
Mhm. Block is physical division, right? Block
Which
is
will
a
be supplied to Mapreduce program. That is a input.
sorry.
So it is a logical division which will be supplied to Mapreduce program. That is input split.
It will not be supplied. It will be read actually. Okay, yeah,
Read.
you are right. Yeah, let me explain what is a block. Block is a physical representation of piece of data which stores in a one node, right? Physical representation of piece of data which will store in one node, one of the data node, correct? Any one of the node. But input split is logical representation of piece of data which will process by one mapper, one map. If I have a 4 splits, 4 mappers. Okay. And also I have shown one example. Your input split size may vary beyond your block size. I think one of the example I have taken with my full name and I have broken into pieces. Then I have explained that in previous session.
Yeah,
Sir,
Ravi.
no? Yeah. Please try to revise that once again. So this is most important. Input splits, block size, those are quite important. Okay. And also I have told another one more. In between your map and reduce, there are few more processes goes through. That is sort, shuffle, combiner, partitioner. There are few operations will go through. It will go through. We will talk about them in the coming sessions. Okay. Partition is nothing but which key has to go to which part. Do you guys remember our bucketing? Do you guys remember our bucketing?
Yeah, hash code we used to.
Same here also. The hash code will be applied on the key. And okay, let me just introduce that and we will break. Okay, partitioning. Okay, in Mapreduce partitioning it is. It's not the high partition or something. Okay, so I have a map 1, map 2, map 3, map 4. So which outputs will be collected here and it will be taken the data. Then it will go to one reducer. Well and good, no problem at all. You don't need a partition here. You don't need a partition here because the whole data is going to single reducer only. It's always go to single reducer. There is no problem at all. You don't need any partition here. No partition required. No partition required because one reducer only. But suppose if I have the same operation with the multiple reducers, let's say I have a mapper 5 and so on. I have one more reducer. Now tell me which key will go to our reducer 1, which key will be key value pair, right? Actually the reducer also takes the output of the mapper, right? Which key value pair will go to reducer 1, which key value pair will go to reducer 2, which key value pair will go to the reducer 3. How will you tell that? We cannot tell, right? We don't have any control on it, right? We cannot tell that. To control it, we have something called partitioning. By default, hash partitioning. What is the hash partitioning it does? It takes the key modulo, it takes the hash code of the key. Okay, hash code modulo by number of reducers. If the remainder comes 0, it will go to here. If the remainder is 1, it will go here. If the remainder is 2, it will go here. The key will go. Same your bucketing concept only in the Mapreduce also. Partitioning. Partitioning, what people may ask, what is a partitioning? When you have a multiple reducers in the Mapreduce framework, our partition logic will define which key has to go to which reducer. Our partition logic will define which key value pair has to go to which reducer. That's called partitioning. Okay, there is something called combining. Combiner. There is something called combiner. Okay, combiner is mini reducer. Mini reducer, we can call it as a mini reducer. What it does, you know, it before it goes to reducer phase, it applies some logic in the mapper itself. We will discuss in detail when it comes to the respective program or example. Suppose this is one of my node, one data node. In this, there is a possibility mapper 1 and mapper 5 is running. It's possible. One node, multiple mappers can run. So there is no restriction here. Okay. This, after collecting the data, I need to do some aggregation. Okay. The reducer will do an aggregation. Similarly, other data nodes also. So what combiner will do, before I send the aggregated data to reducer, actually reducer is meant for aggregation. Okay. So it does the aggregation here. It means mapper level aggregation it does. So if you do the mapper level aggregation, it is reduce the burden on the reducer. It reduces the burden on the reducer, because suppose the reducer is processing, this reducer is processing 10,000 records. Let's assume that 10,000 records is processing. But if I process mapper level here itself, some burden will be reduced. So when it comes to the reducer, the burden may be only 5,000. Instead of 10,000 records, it reduces to 5,000 because it's already done some aggregation part here. I'll show you in detail, okay, how it will reduce, how many keys. This is a network, right? From mapper to reduce, it's a network only. So it actually avoids network bandwidth. I mean, it reduces the network bandwidth. Suppose from this data node, 5,000 records has to transfer, mapper 1 and mapper 2. If you use the combiner, it may make it only 2,000. I mean, it means it reduces. Local aggregations happen. I'll show you in detail, don't worry. Okay, so that's what I'm trying to say. If anyone is more interested to understand about the Mapreduce framework, partition, combiner, grouping, all this stuff, please go through our YouTube channel. Mapreduce playlist is there where I have explained in detail. For the programs, you can go through my GitHub. Okay, actually today I want to I thought to show you execute the Mapreduce program and run. Okay, but I didn't find any of the jar. Okay, after writing your Mapreduce programs, guys, you have to create a anywhere you see jars, input data jars. Okay, it has some jars. Okay, here I have some jars. Let's take a word count jar. Okay, word count jar. Okay, word count jar is nothing but what are the program I have shown here, right? That program will be built as a jar. The program, suppose if you want to deploy into another cluster and all, it has to go either jar, either .gzip, or it has to go in one of the format. Okay, it's not blindly go ahead and run the code. You have to build it. When you build it, it will create a jar. That jar only will execute. Okay, I have a jar here now. Let me try building. Whether it's working or not, I don't know. Let me see first my services are running fine or not. Data node, name node, resource manager, node manager, secondary name node. Yeah, all services are up and running. Let me close this. It's a very old VM. Okay, so okay, I need to identify the input also. Okay, first I need to identify the input. HDFS. Okay, let me go web UI. Let me see in web UI. We'll just execute one program in the MapReduce and I'll wind it up here. Tomorrow I'll show you the what happens in the background from the file system level. Okay, then you can uh, localhost. It has been quite a while actually. Okay. I will be having some data for the word count. I'll be having some data for word count. Okay, I'm very much sure about it. Okay. Let me look at the data. File 1. What is this file 1 contains? It has only one block, right? Okay, only one block means only one input split will come. We're trying to connect the host. This is the data. I don't want this, but any let me take different data. Word count. All processed data only it is there. Part R means processed data. Okay, part M, part R, these are all processed data. I want some data which has a simple text. Input stock data. But this is also will be different way. No? Yeah, all are these categories, all these ones. Yeah, I think this data I can make use. Sample2.txt. It will be normal text. Hi all, how are you doing? How is preparation? Okay, so now I'm going to count the how many words are there in this and word frequency. Hi, how many times it came? How many times it came? Are you doing? All these things, how many times it came? We will see. If you want me to take another example, another data set, I can take another data set also. So block size you see here 32 MB. I have set it up 32 MB. Okay, I'll take first sample only. Let it actually work. Okay, user sample2.txt. Okay, So how the command runs to run the Mapreduce job? If I remember correctly, Hadoop jar path. Jar path is oh, Hadoop desktop jars word count or jar. Yeah, Hadoop jar path. Okay, I need to give the complete fully qualified class name. Oh, that's the biggest challenge now. The biggest challenge is I need to give fully qualified class name. I don't know what fully qualified class name I have given here. Let me try any of the. We need to give the driver name. Okay, so try Anja here. I'm trying to see what is the class name I have given. Com Hadoop job. Oh, there are a lot of not com Hadoop job. I can give word count dot job. This I think I can give this word count dot job. Yeah. Your fully qualified name is com dot Hadoop dot job dot word count job. Word count job dot class. Okay, word count dot job. Okay. Then I have to give fully qualified class name, driver class name, then input. So input I just saw here, right? That input is user /user sample2 /user sample2 /user sample2 dot txt. Here output also, input should be HDFS, output also should be HDFS. Here /user I'll just give today's date 05/08 word count 2020 word count. This is my output folder. It should not be exist. Should not be exist. If it exists, if you want, you can delete in your program with in your program. By default, it will not get deleted. Okay. Otherwise, if you want to delete, you can do it manually. Let's see whether it will run or not. Hadoop jar path class name use input output. Okay. Connecting to the resource manager. Total input path is 1. Total split is 1 because small file, right? Okay. Job is launched. Very good. If you want, you can track it here. The same as your resource manager. Okay, you can see here. Or else we'll launch our resource manager. Eight zero, if I remember correctly, it's 8088 or 8080. Yeah, here it is opened. Yeah, look at here. This is your job. It's running. It's running. Okay, only one mapper is The reducer is not yet started. Okay, I don't know what happened, why it is taking this much time. Something when, oh, job failed. Why it is failed? uh, Something because we didn't take proper way, right? Word count job, word count mapper, no such method. Hmm. Let me try with another program. Word count combiner. Let me see inside the jobs. Word count job. Okay, here word count job is there. Let me launch that. But launching it the same way, okay? Because I don't have a source code. Okay, I'm just going through the jars. So whether those jars are correct or not, also I don't know. But let me do here jobs. But I want to demonstrate you guys. Let complain that output is exist. I don't think. Yeah, output directly exists. It compliance that. If you want to see the complete demo, that's there in that video. You guys can have a look. Okay, this is just I want to show you how it take the input. What is the command? Hadoop jar path and your fully qualified driver name and input and output. It looks it is starting mapper phase. No, it is not started. Okay, yeah, it's running, guys. Mapper is 100% completed. You can see the same here in UI. You can say here 2 instead of 1 because the job name, job ID is that. Second job, it looks quite slow. This is the job ID. Succeeded. One mapper. Finished. Look at here, guys. This is the finished. Okay. So finished, succeeded. Okay. If you want to see, you can just click on this. You can go down. You can click on the logs. This is how we'll do the debugging. Okay. Even Spark, even whatever it is. Click on logs. You'll go to the logs. Okay. Here, your error logs, sysout logs. If you have any other logs, it will display here only. Okay. So you'll go to respective logs and we'll see. Try to remember this. This is how we'll see the logs. No matter whether it's a Hive job or whether it's a Scoop job or whether a Mapreduce job or Spark job. So go to the resource manager and go to the application ID and see that what is happened. Okay. Now, so what we have done, we have given input and we have given output. Correct? We have given input and we have given output path. Go to that output path now. Go to output directory. Here only we have given output directory, right? I'll just we have given with the date. This one. The first one is failed one. This is a success one. Okay, this is success one. So you can see that underscore success will be there. It is empty file, guys. Okay. Do you guys remember one time I have asked earlier what is the purpose of the command touch command? Do you guys anyone remember touch command? We have a touch in HDFS. So to create empty file, what is the purpose of the creating empty file? To capture the timestamp. So when this job is success, so whenever this success underscore success file is created, so it will capture the timestamp. Okay, it will not contain it, but it when you want to know the timestamp, you can with the help of this we can get that timestamp. Go to this program, download, and you can see the output of this. All one time, or one time, based one time, doing one time, how two times, is two times. So this is the program output. I mean, this is what I was expecting. This is the same output came. Okay. Is that clear to everyone? You
Yes,
have a
Ravi.
more, you have more demos in that our YouTube video playlist. You can go through it. If you find any difficulty, please let me know. I'll try to make you understand. Okay, that's it for today. Tomorrow we'll continue with the Spark, but tomorrow I want to show you one more diagram. It's how the data will read from the system, I mean, which is called HDFS, how it will split, how the record reader will launch, how the mapper will launch, how the reducer will launch. That flow I will show tomorrow. Then we will jump into the Spark part. That's it for now. If you guys have any questions, please stay back and ask me. Uh, if not, we can leave for the day. It looks no questions. Thank you guys. Thanks for your time. Have a wonderful day.
Thanks, Avi.